I'm going to start talking about set theory in this video. So set theory is a very fundamental concept in pretty much any advanced math that you'll go into. There's a lot of definitions. You will, as you go through more math curricula, get these very reinforced and they'll seem like second nature to you at some point. A set is a collection of objects in the most broad sense. In math, this is often going to be a collection of numbers or functions or some sort of mathematical structure. It doesn't have to be though. So an example of a set could be something like 1, 2, 3. This is the set containing the numbers 1, 2, and 3. And whenever we write a set, we do enclose it in these curly brackets. This is the set containing 1, 2, and 3. And this other one right here is the empty set. We can also write the empty set like this. Like I said, a set can be any collection of objects. It can be Data, who's my cat, Wesley, who's the cat next door, and Baby Yoda, who lives across the street, also a cat. So it can be a collection of cats. It could be functions. F of x equals x squared. When we have three objects or three functions, something like this, it's obviously very easy to just write them out. I did all examples with just three things because we can just list those out very easily. But say we wanted the set containing the numbers 1 through 20. Sure, it doesn't take that long to write the numbers 1 through 20 down, but you can also use ellipses, as long as it's clear what you're doing here. So if I do 1 dot 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 20, people will just assume it's the integers 1 through 20. You do want to make sure that you put enough information at the beginning and at the end so that people do understand what the set actually contains. An example of something that might not be so clear is, say I just did something like 2, 4 dot dot dot. And then you might be like, okay, is that going to be the even numbers? 2 to infinity. But it also could be like the powers of 2 maybe. 2, 4, 8, 16, and so on. Be cautious, and if it looks like there's room for misinterpretation, write your set differently. Often when we have a set, I don't want to write this out over and over. So oftentimes we'll give a set a name, just like a variable. So for example, I could say A is the set containing 1 through 20. And then if I want to talk about this set, I can just use A in the sentence or in my proof. So I could say something like, the number 26 is not in A. I can just use this now once I've given it a name. And one thing to know about sets is we often name them using capital letters. You don't have to do this. You could name it T-Rex if you wanted, but they're often named using capital letters, and sticking with standards that are already in place in math can make something more readable to somebody who is used to the things that are considered normal or considered standard. So another way to write out sets, for example, if we're in, this situation where I'm like, okay, there's a problem because there's ambiguity, is something called set builder notation. Let's do the set of powers of 2. If we wanted to express that maybe P is the set of powers of 2, we could write this using set builder notation. This is going to represent the set of powers of 2. Another way we can write this is we can write it as the set of all x such that x equals 2 to some exponent, where that exponent is bigger than or equal to 1. We're saying that the set contains all values x, where x is a power of 2, and the exponent on that power of 2 is at least 1. Another way that we could do this is we could actually just say we want the set of all 2 to the e, where e is bigger than or equal to 1. So this is saying our set contains all powers of 2, where the exponent is again at least 1. So I do keep putting this weird vertical bar in here. And when you see this vertical bar, you want to read it as such that. I'm going to restate what these sets are, reading it using the term such that, so you are clear on how these are read and what they mean. So this set right here is the set of all x such that x equals 2 to the e, and e is bigger than or equal to 1. And the second one we read as the set of all 2 to the e such that e is bigger than or equal to 1. I am replacing that vertical bar when speaking with such that. We can also use a colon, and it means the same thing. So these would be read the same way. So this is again set builder notation, and it's a more compact way of writing sets. And sure, it's a little strange when you first see it, but it is so ubiquitous in advanced math that it is something that you will get used to with time. Let's do more terminology. A set contains objects, but the objects are called either elements or members. And I would say from my experience, the term elements is more commonly used, but people will understand members as well. For example, if P is our positive powers of 2 set, we could say 2 is an element of P. We can use the word member in the same way. 16 is a member of P. And something like 15, which is not a power of 2, is not an element of P. And of course, like I said, we can use member in the same way. So we could say 15 is not a member of P. Both are valid. We do have a shorthand for describing this. We have a symbol, and it makes expressing this concept a lot easier. So if I want to say 2 is an element of P, I use this symbol right here. So it's kind of like this funky E type thing. And this is our set membership or element symbol. So I can say, to say 2 is an element of P, I can equivalently just say 2, put the symbol in, and then P. And someone reading that, who's an experienced mathematician, will just read it in their brain as 2 is an element of P. 16 is also an element of P. And if something is not in the set, if something is not an element of the set, we express that with the same symbol but with a slash through it. So 15 is not an element of P. To recap and just put them here, this means is an element slash member. And this one means is not. And this putting a slash through a symbol is really going to carry over to a lot of different things in math. I mean, you're already used to the difference between equals and not equals, right? Putting a slash to the equal sign. And this notation will end up being used in other ways as well. For example, if you get to congruences, we have congruent and not congruent, and so on. So the slash will often mean not. So we'll stick with just that for terminology for this video, but let's do a couple more examples of writing sets. I did say earlier we can use ellipses, and you can actually use these multiple times when expressing a set. So say I wanted to express that we had the set of all even integers, including the negative ones. I could do -8, -6, -4, -2, 0, 2. I could do ... There we go. 2, 4, 6, 8, ... This set contains all even integers from -infinity to +infinity, all even integers. So here I've used 2 sets of ellipses, and that's totally fine. You can use as many as you need to express your set precisely. Also, that set builder notation that I was talking about, we could say for this first set right here, we could say or express this as the set of all x such that x is an even integer. This is, again, a more compact way to describe this set. We could also describe this as, we could say it's the set of all 2x such that x is an integer. So if you went ahead and plugged in 1, 2, 3, 4, 5, and so on into this 2x right here, you would end up with 2, 4, 6, 8, 10, 12. So if you double all of the integers, you're going to get all of the even integers. So these are all the same. Say we wanted to express fractions. We could express them as the set of all a over b such that a and b are integers. This would be the set of all fractions. Oh, I should do something here. Add in b not equal to 0 because you can't ever have a denominator of 0. This is actually the correct way to express this. I want to emphasize that you really, really want to have precision when describing your sets, even if it means putting in detail that you think is already pretty obvious, that the bottom of a fraction is never going to be 0. It's still a good idea to add that in as well. All right, that is it for this video.
Sorry, I was talking to a bat. He's gonna be okay.